Welcome, Krzysztof. I'm glad we were able to get over those troubles.
Yes. Hello.
Yeah, we can hear you very well. We can see you. We can see the presentation. So without taking more time, I'll let you start your presentation.
Yeah. Hello, everybody. I'm sorry for that technical problems, but I had to change my computer. Probably some firewall blocked my camera and microphone. My name is Krzysztof Fornalski. I represent Faculty of Physics, Warsaw University of Technology, and together with my students, I would like to tell something as a, in fact, supplement to the information given by the previous presenter. So it is a good thing that I'm the second one. I will tell you something about radiosensitivity and something similar as a radiosusceptibility. And radiation adaptive response. Those two items, which are probably the two sides of the same coin. So just at the very, very beginning, maybe some repetition of what you heard in previous presentation, that ionizing radiation can create some damages inside our DNA chain, which is connected with so-called deterministic effects, what are short-term effects. After that, after mutation accumulation, we can have a cancer transformation of the cell, which is a stochastic effect. It is long-term effects of ionizing radiation. So in the case of what we heard just at the beginning, of course, ionizing radiation can be potentially very dangerous for our health. And in the case of space radiation, it is potentially very harmful. But we have radiosensitivity. What is that? It is overreaction of the organism to ionizing radiation in relation to deterministic effects. Analogically, radiosusceptibility is the same overreaction, but related to stochastic effects, so cancer. What does it mean? Generally, we observe that the radiosensitivity is different in the population. So every of us has different level of radiosensitivity. More than that, this level of radiosensitivity vary over time. So potentially, we are able to stimulate its level. Of course, there are some other aspects like hyperradiosensitivity, extreme version of radiosensitivity, which is usually found in cancer patients. For example, we have also radioresistance, which is just a reverse of radiosensitivity. Here you can find some exemplary results how the radiosensitivity can be measured. Here on the left, you have some control group. On right, you have cancer patients. So it is clearly seen that among cancer patients, you have some individuals with high radiosensitivity. So generally, radiosensitivity, as many traits in populations, are described by Gaussian distribution, which is something standard. Of course, this was tested also for astronauts, especially Russians has tested that. You can find the reference for that paper of Mrs. Voryobova and Professor Mortazavi, who published a few papers about that, and he stated that the potential crew members can be tested for such a radiosensitivity. He proposed so-called Yonezawa effect for them. It is the special scheme of testing the radiosensitivity where you irradiated the organism by low dose, after that by high dose. Of course, we are talking about blood samples, not the whole body, and check the level of radiation adaptive response. And he proposed that during the mission, chronic exposure to elevated levels of space radiation can considerably decrease radiation susceptibility. So I think that it is the next potential solution what to do, according to what Roberto said in previous presentation. Here is Professor Mortazavi on right. I met him 5 years ago in Warsaw. So what next? Of course, the ideal situation is when we have one universal test of personal radiosensitivity, which will be able to inform us if some individual is radiosensitive or not. However, it is very problem to create such a test because those tests are very limited. They are limited to exact type of radiation, to exact type of organs, and so on. At this moment, recent activities are focused on multiparametric tests based on in vitro irradiation of blood lymphocytes and skin fibroblasts. So most at this moment areas of research are focused mostly on cancer patients and in some small part also for astronauts. The second topic what I would like to present is so-called radiation adaptive response, called also the radioadaptation. This effect gives us some protective mechanisms which enhanced natural repair mechanism because of stimulation of some stressor. It can be some medicine, or in this example, ionizing radiation, especially very low doses of ionizing radiation. Adaptive response is an example of so-called non-targeted effect. This effect is very complex and not fully understood. More than that, it is generally very rare situation. So adaptive response not always appears. It is the very important message. Approximately less than half of people will show some form of adaptive response. So it is absolutely not for everybody. So it is the reason why in radiation protection, this effect is generally omitted. From the historical perspective, first experiments were carried out during the Manhattan projects. It was called Recovery from Radiation Damage by Professor John Rapper. The first time the term adaptive response was proposed in 1984, and many experiments about radiation adaptive response are presented in ANSCER report in 1994. ANSCER is United Nations Scientific Committee on the Effects of Atomic Radiation. Since last year, I'm the member of Polish representation to that committee. Our recent knowledge, it is based on very recent paper, is that radiation adaptive response is a complex response of the organism to ionizing radiation, which stimulates different mechanisms of various levels, like DNA repair mechanisms, antioxidant response, immunological response, apoptosis regulations, which is probably the most important here, cellular response, cellular cycle regulations. But as I said, those effects are quite rare and subtle, thus it is hard to determine them. So every experimental scheme shows this, not every experimental scheme shows this effect, even if we try to organize everything as it should be visible, it is, let's say, 50% to chance to see it. But what we can do? We can, of course, propose some model. And a few years ago, we created dose and time-related model, fully mathematical one. I have no time to present every details of it, but generally our model is quite universal and can describe the adaptive response in various aspects, especially two most important or most frequently found ways how we can observe such an effect. One is a constant dose rate. So, for example, in space or in high background radiation areas where people live there for generations, or so-called priming dose effect, called the Rapper-Yonezawa effect, or simply Yonezawa effect, which can be presented like here, when you have two colonies of the same organism. First colony is radiated by high dose. After some time, you can see many detrimental effects. But if you have a second colony, if you treat them by low dose, you wait some time, few hours, 10 hours, 20 hours, depends on the organism, and you treat them by the same high dose. And in the first case, you will see that those effects will decrease. Negative effects will be smaller. As I said, not in every case it is observed. There's 50%, 50 chances that this effect will be observed. In the second special case, as I said, constant dose rate, we made Monte Carlo simulations, which we observed that constant radiation will create a saturated version of adaptive response probability function, which can be also calculated in analytical way based on our biophysical model. I have no time for a detailed explanation. However, we can see that the effect will be also observed here. This effect would be potentially smaller than in Yonezawa effect, but however, it is possible. So how to check it? So we can check the scientific papers on high background radiation areas. We tested 5 studies on chromosomal aberrations on blood lymphocytes, and we observed that in approximately 40% of cases, we can observe the radiation adaptive response for that situation. The average level or the level of ionizing dose rate of ionizing radiation is approximately 2 microsieverts per hour, which is the level when we, up to our model, we can expect the highest probability of adaptive response. But of course, as I said, it is not 100. It will be never 100%. So, as I said, 2 sides of the same coin. So what is the relation between adaptive response and radiosensitivity? There are 3 hypotheses. One, that radiosensitive individuals response in adaptive response. Second, that radionormal. And third, radioresistant. So which hypothesis which should be taken? Well, there are data supported for all of them. However, our studies showed that the third one is probably the most appropriate one. So we support the third hypothesis, where the most radiosensitive people has the lowest probability of adaptive response. So the opposite, the radioresistant individuals will present the adaptive response. So the question is if radioresistance is the result of adaptive response, or the opposite, the adaptive response is a result of radioresistance. We showed that the low dose rate stimulation induces adaptive response, which is probably increases radioresistance among individuals, which can be potentially applied to cosmonauts, to astronauts. So to conclude, we discussed here the dose rate, so the constant level of ionizing radiation as a situation common in space, which can induce the adaptive response phenomenon with some probability. Our studies and earlier studies by Professor Mortazavi support the hypothesis that strong adaptive response can increase the protection of astronauts. So that's all. I see that I'm almost in the time. So thank you. There are 2 references and contact to me if somebody is interested in the subject. Thank you so much.
Yes, thank you, Krzysztof. Sorry for the issues, for the technical issues. They're unavoidable sometimes. I can see in the chat box not a question but some suggestion and invite for discussion. So you might be up for it. Yes, unfortunately, we have to end our session. The next session is starting in a minute. So thank you, Krzysztof.